Limit as x goes to 0 sine of 6x divided by sine of 3x. First thing we're going to do is try plugging a 0 in for each of the x's. That'll give us sine of 6 times a 0 divided by a sine of 3 times a 0. 6 times 0 is 0. 3 times 0 is 0. We have the sine of 0 over the sine of 0. The sine of 0 equals to 0, so we have the 0 over 0 indeterminate form. Since this is coming from sines with different phases, we're going to be making use of the identity. Limit is theta goes to 0 of sine of theta over theta. Also, limit is theta goes to 0 of theta divided by sine of theta. Both those are equal to 1. We have a sign in the numerator and denominator. What we need to do is isolate those signs by putting them in their own fractions. The sine of 6x is in the numerator. The sine of 3x is in the denominator. And we need to, according to the identity, match the phase in the other position. So we have a sine of 6x in the numerator. Its phase is 6x. We need a 6x in the other position, being the denominator. To compensate for that, we're going to put a 6x in the numerator in its own fraction off to the side. The other sign of 3x in the denominator has a phase of 3x. We need to match it in the numerator, and in the separate fraction we'll put a 3x in the denominator to compensate for it. The x's in that fraction can cancel each other out, and so we're left with limit is x goes to 0 of sine of 6x over 6x times 3x over the sine of 3x times a 6 over a 3, which can be reduced, and we'll reduce it by 3 to a 2 over 1, so just times a 2. We have the identity happening. We've matched the phase with the other position. This will be a 1. This will be a 1. And therefore, our limit result is going to be 1 times 2, which equals to 2.